Have you ever picked something up at the store, looked at the label, and just got a feeling like, am I really getting what I paid for here? Well, today, we're going to do more than just wonder. We're going to put a company's claim on trial, and we'll see if we can use the power of statistics to figure out the truth. So, meet our defendant. This can of Hilltop coffee. The label makes a simple, clear promise. Right there, plain as day, it says, this can contains 3 pounds of coffee. No asterisks, no fine print, just 3 pounds.
But is it really? I mean, is that a rock-solid guarantee, or is it more of a friendly suggestion? That's the big question we're going to dig into. We've got a hunch they might be shorting people, but how in the world do you actually prove something like that?
Well, here's the first rule of this game. You can't just rely on a gut feeling. We can't march into their headquarters and say, hey, I feel like these cans are a little light. Nah, that won't work. We need a formal, fair process. We need cold, hard evidence.
And this brings us to the core idea we're talking about today, which is called hypothesis testing. And honestly, the best way to think about it is like a courtroom trial. We have to start with a fundamental principle. The company is presumed innocent until we can prove them guilty.
And this is ground zero for our entire investigation. Just like in a real court, we have to begin by assuming the defendant, in this case the coffee company, is telling the truth. We take their claim of 3 pounds at face value. That's our starting point.
So, you can see our statistical trial has two competing stories. On one side, you've got the company's claim. We're honest. They say the average can, which statisticians call mu, is at least 3 pounds. But on the other side, you've got our suspicion. They're underfilling. We think the average can is actually less than 3 pounds. Now, in statistics, these ideas get formal names. The company's claim, their plea of innocence, is called the null hypothesis. We write it as H0. Think of this as the default position, the status quo. We assume this is true unless the evidence is just too overwhelming to ignore.
And our suspicion? Well, that's called the alternative hypothesis, or HA. This is the prosecutor's argument. It's the theory we're trying to prove. We believe the cans are underweight, and now it's our job to gather the evidence and see if we can make our case.
All right, court is in session. We've got the charges set with our null and alternative hypotheses. Now, it's time to bring in the evidence.
So, our investigative team went out and gathered a sample, 36 cans of coffee, to be exact. We weighed every single one, and the average weight came out to 2.92 pounds. Now, that is less than 3, but here's the million-dollar question. Is it significantly less? Or could that tiny 0.08 pound difference just be random noise, normal variation in the machinery?
To answer that question, we need a very special tool. We need a way to measure just how surprising or weird our evidence actually is. And that tool is one of the most important and maybe most misunderstood ideas in all of statistics, the p-value.
Okay, so just imagine for a second that the company is totally innocent, right? This bell curve shows what we'd expect to see. If the true average really is 3 pounds, then most of the time we grab a sample, the average should be right there in the middle, super close to 3. Getting an average of, say, 3.01 or 2.99, totally normal, nothing to see here. Which leads us to the real question. Assuming they're innocent, and the real average is 3 pounds, what's the probability that we would just randomly happen to pull a sample of 36 cans that averages as low as 2.92 pounds? Just how weird is our result?
And boom, here's the answer visually. Look where our 2.92 lands on that curve. It's way out there in the tail. The p-value is simply the probability of getting a result this extreme or even more extreme. It's that tiny little shaded area, and it basically represents the surprise factor of our evidence.
And when you run the numbers, the p-value for our evidence is 0.0038. Wow, that is a very, very small number.
Let's put that into perspective. This means that if Hilltop Coffee is being honest, there's only a 0.38% chance of getting a sample this underweight just by pure random luck. We're talking less than 4 times in 1,000. Suddenly, our evidence is starting to look pretty darn convincing. Okay, we've got our evidence. We know exactly how surprising it is. It's time to take off our investigator hats, put on our judge hats, and deliver the verdict. Here's exactly how the decision gets made. It's a simple process. First, we've got our p-value, 0.0038. Second, before the investigation even began, the director set a line in the sand for what counts as too surprising. They chose 1%, or 0.01. This is called the level of significance, or alpha. So third step, we compare. Is our p-value smaller than that cutoff? Is 0.0038 less than 0.01? Yes, it is. Our evidence has officially crossed the threshold from maybe it's just chance to, whoa, that's statistically significant.
And this isn't just us making a judgment call. There is a formal rule that guides this whole decision. It's simple. You reject the null hypothesis, the claim of innocence, if the p-value is less than or equal to that alpha level you set. Our number is smaller, so we follow the rule.
And so the verdict is in. We reject the null hypothesis. We are throwing out the company's claim of innocence. The evidence is just too strong, and it overwhelmingly suggests that Hilltop Coffee is in fact underfilling its cans.
But hang on a second. In statistics, just like in a real courtroom, we're almost never dealing with 100% certainty. Our verdict is based on probability, not absolute ironclad proof. So, is it possible that we got it wrong?
Oh, absolutely. And there are two specific ways we could be wrong. Look here. It's possible the company was actually innocent, and we just got a fantastically unlucky, super lightweight sample. Convicting an innocent company based on flimsy evidence? That's called a type 1 error, and the chance of that happening is actually that 1% threshold we set at the start. But there's another mistake. What if the company really was guilty, but our evidence just wasn't strong enough to prove it? We'd let them off the hook. That's a type 2 error, letting the guilty go free.
And that, right there, is the most important takeaway. Hypothesis testing isn't a magic 8-ball. It doesn't give us absolute truth. What it does give us is an incredibly powerful and logical framework for weighing evidence and making the smartest possible decision, especially when we can't be 100% certain.
So we use this whole process to investigate a can of coffee. But this exact same logic is used to test if a new drug works, if a financial strategy is profitable, or to check claims made by advertisers. So it leaves me with one final question for you. What claims in your world, at your job, in the news you read, or on the next product you pick up, deserve a closer look?